So the circles represent the area of my backyard lawn that my sprinkler system covers. You can assume that all circles touch the next closest circle. If the width of the lawn is 28 and 6/12 feet, what percent of my lawn will not be watered by the sprinkler? So again, making sure we're defining, we want to know what's not going to be watered as a percent, knowing that the width is 28 and 6/12, and that we have this picture. So let's see if we can figure out what we know. Now, when you say the width, which one is he talking about? Is he talking about 1, or is he talking about 2? So let's just say, let's pretend like, let's label this in a way that's better. So maybe green versus purple. So say the width were the green one. Suppose that's what we were talking about. That might be one scenario compared to if the purple was it. So we might want to consider, well, first asking the person who gave us this problem, like, what do you mean? Which one are you calling the width? For the sake of this video, I'll do it both ways, just so you can kind of see, a similar problem twice. So, suppose the width were the green one. So this is 28 and 6/12. 6 divided by 12 is the same as a half. So 28 and a half, 28.5. You'll notice I go to decimals when I don't have to go into a rounding scenario, knowing that I can use my calculator to get back to fractions if needed. The second I start rounding, this is the second I start causing some trouble. So then how do I know? Well, these sprinklers, they cover the inside here, right? So they're getting all this, but they're not getting the stuff in between. So how do I know how much one of the sprinklers is covering? Well, if you draw this special line through each of these circles, that goes through the center and goes from edge to edge, we call this dimension the diameter. And the diameter is important because we're trying to find how much area each sprinkler covers. What area, how much water from an area perspective is being covered here. Well, the way we find the area of a circle is pi times radius squared, or times itself, is the area of a circle, which is how much area that covers. And the radius is just half the diameter. And so since we know these sprinklers are look the same size, they touch at one point, we know we have 1, 2, 3, 4, 5, 6, 7, 8, 9 diameters, which means we have 18 radii, twice as many, because the radii goes from center to edge, and so we have 2 centers to edges, and so we have 18 radii. So how long is a radius? Well, I take 28 and a half, and I can divide it by my 18 radii to tell me how big one of the radii is. So sometimes this crashes. Sometimes it takes a restart, so I apologize real quick. This is just an emulator. Your calculator won't have these issues. See the calculator, good, and we are ready to go. Alright. So, what I was doing was I was dividing 28 and a half by 18. So each radii is 1.583 bard, which again I can convert to fraction form. Math, frac, enter, 19/12. So each radii is 19 over 12. And so I can also use that to find the width, right? Because I have 1 radii, 2 radii, 3, 4, 5, 6. I have 3 circles going down. So I know I have 19/12, 19/12, 6 19/12. 6 19/12 is times 6, 9 1/2. So this is 9.5 going down. So now I can find the area of the yard. And so if I can find the area of the yard, and I can find the area of the sprinkler coverage, I just take area of sprinklers divided by area of total yard, and that will tell me my percent coverage. Now, I want to know the percent not covered, so I'd have to subtract that number from 100. Alright, so let's do it. So to find, I'm sorry, I erased this. This is a critical point, so that was my width. So the area of the sprinklers is equal to, I have 27 circles, all at pi radius squared, 19/12 squared. And so that is 27. Let's see, pull up the calculator. So I'm used to just reaching for my own. 27 parentheses, so that's times pi parentheses 19/12 squared, close the parentheses. So the area of the sprinkler is 212.646. Again, I can convert this to a fraction. Some gnarly fraction. Alright, so I'll keep that on screen. I can always go back to it. The area of the yard is just 9.5 times 28.5. Again, area, we multiply the dimensions because we're trying to find the coverage, not the fencing. And so doing that, I'll just quickly do that. 9.5 times 28.5, 270.75. So the percent coverage should be this number, the 212 number, divided by 270.75, because you take the part that you want to know over the whole. Now, we don't want to know this part, but this will help us. So it's 70.785398, which is 78.54% covered. And so the percent not covered is 100% minus that, which would give me 21.46% not covered. I could do the problem the other way, and I'm going to pause it, I think, and just show you what I did. Alright, so I'm back, and I computed that the radius would be 4.75 when I changed I guess I was calling it the purple dimension to be the 28.5. All I did was I took the 28.5 and divided it by 6 to get 4.75. I still have 27 circles, so I can find the area of the sprinkler that way. The width now, however, the lawn changes because if 3 circles going down makes 28.5, then 9 circles must be 3 times as big, 85.5. So the area of the yard then, so let's compute these out. The area of my yard, 28.5 times 85.5. So that would be 2436.75. 2436.75 square feet. Because the area is in square feet, we're multiplying feet times feet. Area of the sprinkler is 27 parentheses pi parentheses 4.75 squared, close the parentheses, 19, I'll just write here, 1913 point something something. So I'm going to take that number in my calculator, divide by the 2436.75. That tells me how much is covered, which is again 78.54%, which means not covered is the same. So regardless of which one I consider the width, the percentage is the same, which is pretty cool. To the last question, if each sprinkler puts out 2/3 of a gallon of water every 40 minutes, what would the dimension of a cube-shaped tank be in order to hold the exact right amount of water to water for an hour? So, so we need to be able to cover the whole yard. There's a lot of presumptions in this question, and I would ask a lot of clarifying questions, right? Some of the things about math isn't just doing the problem. It's trying to figure out, well, what do you still need to know in order to do it? So one of the questions is, I would think about is the whole yard or just the sprinkler covered part? Because if it's just the sprinkler covered part, well, I just need to find how long it would take to cover the area. The other thing is, what kind of depth do I need to call it watered? Right? Because if we're talking about like, it needs a millimeter of water, well, that's different than if it needs like a few inches of water, right? Because if you can picture the yard, and these circles that kind of cover it, does it need to seep down into the grass lower, or does it just need to touch the top? So there's lots and lots of things that you're going to need to know in order to do this. Yes, you could figure out that there is a rate here, a flow rate of 2/3 of a gallon for every 40 minutes. So if I get 2/3 every 40 minutes, that would be the same as getting 1 gallon per hour. Because if you take 2/3 divided by 40, you get that number. And so then how much in 60 minutes? One gallon. So I get a gallon, fine. Another question to ask is how many gallons or how many feet covered, cubic feet covered by gallon. Because my problem here is in feet, and I don't know how to convert from gallons. So there's a bunch of things to think about that you need to be able to answer in order to answer this question. Some of which are user-defined, right? So math isn't just this straightforward thing. A lot of it it depends on what you're asking me for. So these would be the questions I would need to ask in order to provide a solution.